Hello everyone. So today we are going to do Leetcode Daily Challenge My Calendar 1. So in this question we are given with this particular, and this is the thing which we are given, and we are required to return this. So what all this means? Now here the thing is that you are implementing a program to use as your calendar. We can add a new event. If adding the new event will not cause double booking. So basically here double booking, what they mean is that the events shouldn't overlap with each other. That's the thing they want to say. So they told that two events have non-empty intersection, that is known as double booking. That is, some movement is common between both events, means both of the events are intersecting. The event can be represented as a pair of integers, start and end, that represent a booking on half open interval. The range of real numbers x such that start is less than equals to x is less than end. So we are required to implement this my calendar class, and in this class we are initializing the calendar object, and we would be having a function boolean book where we would be passing start and end. So we are required to return true if event can be added to the calendar successfully without causing double booking. Otherwise we will be returning false, that we do not want to add this particular event to the calendar. So this is the whole thing which we would be doing in this question. Now consider that how we would be coming up with the logic of that how we need to specify a particular event as that are we going to add this event to the calendar or we are not going to add this event into the calendar. So that is the thing. So here they have told that how this particular would work. It would be something like this, that when my calendar, this particular would be called, then first it will be calling the function at the starting. It will return true when there are no events are there. So the first event which could be added, that would be returning true, that we can add this event, because when there are no events, then there won't be any overlapping sort of thing. Now we need to check for the second event. Does it overlap with the previous event which was added or not? So that's the thing which we are required to see here. So if we see the 10 and 50, 10 and this 20, this is the thing, and then 15 and then 25, both of them are overlapping. So they come under this particular condition, that is the case 2. That is A is starting first and B starting after the A, but A1 is ending beforehand and B1 is ending after this particular after the particular event was being ended. So here comes the intersection portion. So that's why it comes under this scenario. So that's why we will return false here. Now in this 20 and 30 part, only 10 and 20 were added. So 20 and 30 parts come here, right? So here it comes not even in this case, it comes in some other case when there is overlapping thing. Not overlapping, but end-to-end connection is there, means it will be starting from at this point only. So there is no overlap. So that's why this is being added and returns true. So this is the thing for this particular part. Now the thing is that when we are required to return false, right? So that is the scenario we are required to capture in this particular question. And according to that only, we would be filling up our data structure which we are using, because this is the question of basically a design question in which there would be little portion of the implementation. So that's why here more of the implementation is based on the data structure which we use efficiently. So now in this particular, we would be either using a map or we would be even using a vector, but we require pair in which we could store start and end. So that would be the thing here. Now in this scenario, when we are required to return false, means all the overlapping condition we are required to check. The case one which is there, when A0 and B0 are there. So here the thing is that the starting point and the ending point of second. So the starting point of first and the ending point of the second, this is the scenario here. And moreover, the starting point of the second is less than the ending point of the first. So again, it satisfies the scenario, right? So that's why, So that's why this particular is invalid even, required to be added. Now consider second case. Here again, this A0, that is the starting, the first starting, that is this one, means the S1, this one is less than this, and this S2, that is less than this, right? So again the same scenario is followed. Now in this particular scenario, we see this starting and this ending. It follows the same scenario, but the starting point of the second is greater than the ending point of the first, right? So that's why there is no overlapping in this scenario. So only overlapping in these two cases in this scenario. So that's why after aggregating this, it comes out to be something like this. Means maximum out of both of the starting points, means whosoever is starting at first, that starting at the later portion. So maximum out of these two portions and minimum out of these two portions, means whosoever is at the minimum position. These two things we will be considering, and then we'll check that if this maximum out of A0, B0, whosoever would be there, is less than minimum out of A1, B1, then we are required to return false. That is, we won't be adding this up. So this is the thing which we were checking here. In this scenario also, the maximum is B0, right? And minimum is B1, right? So here it satisfies the condition. Now in both of them, maximum is P0 and minimum is A1, and again they satisfy the same condition. So in this third scenario, maximum out of this A0 and B0 is B0, and minimum out of A1 and B1 is this one, right? But this doesn't satisfy the condition, so it is a valid case, so it will return true. So from these two cases only we infer for this particular scenario. So this is the main logic for this particular question. Means after getting fetching some test cases, we come to conclusion that this would be the main logic for implementing this question and returning that is it true or false. So now comes the next part, that how we would be implementing this particular question and what would be the time complexity and space complexity of the same. So time complexity and space complexity would be directly based on the implementation part which we would be doing. So for implementing this, we are directly checking. So for that part, we are taking a vector of pair, where we could have used unordered map also. And an unordered map, there already would be a pair, right? But here we have taken the vector of pair, in which the first would be the start and the second one would be the end. So this is the thing which we are using for our booking event scenario. Now we will be checking each pair which is there in this book, and then we will be comparing that the event which now we are having is the user which is given to us, can we put that into our map or not? For that scenario, we will be checking for this condition which I have explained above. So if there would be overlapping, it will return false. Thus, this event won't be added up, right? And if there won't be any overlapping, then we will add that into our into this particular vector of pair. That is the thing which we are doing, and then after adding that, at the end we will be returning true. So this is a small logic which we will be implementing here. Now comes the part of space complexity and time complexity. So the time complexity would be simply order of n square because of the fact that would be also in the worst case scenario. So it will be because of this fact only, because we are iterating the map elements again and again as we add up a new event. That's why n time it is for this, and if there are n events which are, means if n events are stored till now, then again we are checking, means at the worst case scenario when we have already added n minus 1 events, right? So we would be checking for all these n minus 1 events for a single one event, that is the last nth event. So we are somehow working this particular as if in order of n square, means in the nested loop sort of, that already there are events and we are checking for the events which are already existing in that map, and then we are directly putting that forward again and again by checking it. So that is the scenario here. So that's why the time complexity basically here is order of n square, but the space complexity here is order of n. So this is the thing here. But now in this time complexity part, if we use unordered map, in that unordered map there is order of 1 lookup only, right? Even if we do again and again, then there would be just one, but again the scenario is something like this, that we are just checking for the first and the second of that particular, means it is somehow we are traversing that particular map or vector which we would be using. So yeah, the time complexity would be n square, because here we are not doing a lookup, here we are directly traversing a data structure, so that's why it will be n square only. If we would be doing a lookup, then surely it would have been in order of n only, but here it would be in order of n square, because we are not doing a lookup, we are traversing a whole data structure. So this was all for this particular question. So if you have any doubt about anything, you could comment that down, and please do like and subscribe to my channel. Thank you.